Okay, let's look at June 2017, question 2.1 and 2.2. June 2017, question 2.1 and 2.2. Write an equation including state symbols for the reaction with the enthalpy change equal to the enthalpy of formation of iron 3 oxide. So formation means that you're making 1 mole of something. You're forming it from its elements, so they should contain just symbols, not a combination of symbols, not a combination of atoms, they're not compounds, they're elements, and this should be in their standard states, how you'd normally find them in the laboratory. Let's do the first bit. Let's work out what iron 3 oxide is. Well, iron 3 oxide is Fe2O3, so let's work out why. Iron 3, the oxidation state of iron is +3. 2 plus 3 is a +6. Oxygen is -2 because it's in group 6 of the periodic table, gains 2 electrons, -2. So I want a number that balances out the 2 plus 3 is +6. So this has got to be -6 to leave no charge overall. 3 minus 2 is a -6. So let's just check it out. 2 plus 3 is 3 minus 2's. That balances in terms of charges and oxidation states and leaves no charge overall. Perfect. 2 Fe's on the left, 2 Fe's on the right, 2 Fe's now on the left. 3 O's on the right, 1.5 times O2 for oxygen is 3 O's on the left. In standard states, how you'd normally find them in the laboratory, 25 degrees C and 100 kilopascals, normal conditions for laboratory. If iron's a solid, it's used to make nails and iron gates and things like that, clamp stands. Oxygen's a gas and iron oxide is a solid. Next one. Table 2 contains some standard enthalpy of formation data. This looks a bit trickier, harder than the one we've done before, but it's doable. Use this data and equation for the reaction of iron 3 oxide with carbon monoxide to calculate a value of standard enthalpy formation of carbon dioxide. Okay, standard enthalpy of formation. Okay, we need to see this. Carbon monoxide formation. Okay, carbon monoxide. What's formation again? Formation of 1 mole under standard states, standard conditions of room temperature from elements in their standard state. So carbon monoxide, 1 mole of it. Carbon is a solid. 1C, 1C. 1O, so half O2 gas. Carbon is solid at room temperature, half O2 gas to make 1 mole of carbon monoxide gas. Good. I'm going to get rid of the ones though now. And that is -11 kilojoules per mole. That's the enthalpy change, the heat change for that reaction. Good, I've got one of them. Formation of Fe2O3. Well, I've got that equation here. That's that equation there, which is this one here that I've copied over here. That's that one. Enthalpy of formation of Fe2O3, and that's -822. Okay, we've got this big one here. Yeah, -19. And we've got to find out the missing one is calculate the value for the standard enthalpy of formation of carbon dioxide. So carbon dioxide is CO2. 1 mole of it, if it's standard enthalpy of formation, from the elements in their standard states, how you'd find them in the laboratory. 1C, 1C, carbon's a solid, the middle of your pencils is carbon graphite. 1O2, O2 on the right, 2 O's, 1O2. Perfect. Enthalpy of formation to make 1 mole of carbon dioxide from elements in their standard states as you find them in the laboratory, solid, gas, gas. Get rid of the ones now, simplify it. Now we know we've got it right, and that is an unknown value. That's what we've got to try and find out. We're going to call that X. That's the enthalpy change that we're trying to find out, the delta H, which we're going to call X. Now we need to match it up. Okay, I'm going to take the big equation. That's my big one. That's my one that I'm going to start off with, and then all the other little ones will match around it. Okay, that going to that is like going from Pennypass Car Park at the bottom of Snowdon straight to the top at the cafe at the top, one-step reaction minus 19. Okay, there are other ways up Snowdon, so we need to find the other routes up Snowdon. And if we add up all of the other routes, the enthalpy changes of all the other routes, the other steps should equal this one. That's Hess's law. So let's try and find a match. Right. Okay. This is going to be tricky on a computer because it's harder. I've got an Fe2O3 there, and I've got an Fe2O3 here. So let's take this one and match it up. We've got an immediate problem. Even though we've got a match, this equation across here, the other equations, the other steps need to flow around this way. And it's going in the wrong direction. I want this to come to here and then these to come to here. The arrows have got to flow around in the same way. So I'm going to have to reverse this one. I'm going to have to take it round the other way. See if I can do that. I can take it round the other way and reverse it as long as I swap that symbol. It's a minus, it's now a plus. That's better. Let's match it up again. There's a perfect match. And now it's coming round in the right direction. Okay, what have I got here? Fe going to Fe. 2Fe solid going to 2Fe solid. They're the same. Okay, let's see if I can do this. Insert shape, arrow. That going to that. Well, it's the same. So that must be nothing. So that is nothing there. There's no enthalpy change there because that is that. It's the same. So I could put a nothing over that if I wanted to, but I can just discount it. It's nothing that. It's the same. Okay. What else have I got? I've got a 3CO there and I've got a CO here. Right. This is going to be a tricky one because I've not got a very good match. The match, even though it's CO, doesn't match. 3CO doesn't match with 1CO. So here's Jones's next trick. I can reverse it and change the sign, but I can also change quantities. So if that enthalpy change is minus 111, if I make everything times 3, 3 C's, 3 amounts, 1.5, 3, the enthalpy change, the heat change, because I'm using 3 times the quantities, is going to be 3 times 111. So I've got enthalpy change of 333 kilojoules per mole rather than 111 kilojoules per mole because I've increased the amounts by 3. Now I get a match. 3CO matches with the 3CO. But I've just hit another snag. I knew this question was tricky. The arrow is going in the wrong direction. I want the arrow to come round here. I want all the arrows to come round here from this side round to this side, and it's in the wrong direction. It's going up and I want it to come down and round. So what I'm going to do is I'm going to reverse it. So not only does this one need multiplying, it needs reversing. Instead of minus 333, it's now going to be plus 333. Now let's see if I get a match. I get a perfect match with the 3 COs onto the 3 COs. Yeah, perfect match, and my arrow's coming round in the right direction. Perfect. Where does my last equation fit in? These need to come round to here. So this has come to here and gone to here, and no, that blue arrow is 0. These have got to come round here, and this is my last match. Perfect. Oh, nearly perfect. 1C doesn't match with 3 C's. And the CO2 doesn't match with the 3 COs. So what I'm going to do is, I'm going to times everything by 3. 3, 3, 3, and the enthalpy change will equal 3x, 3 times the amount that I want. I need to still find x. I've had to multiply it by 3 at this point, but we'll be okay, trust me. Now I get a match. Oh, and my arrow's going in the right direction as well. So I've got a match there. Now I need to add everything up. I need a text box to do some calculations. Okay, this one from the bottom of Snowdon straight to the top on the railway is minus 19. So the railway route equals all of the other ways round. This one down to here is a plus 822. This blue one across here is nothing. I'll put a nothing in just to make us happy. Okay, this one down here is a plus 333. And this one coming across here is a 3x. And I want to try and find x. Now I've got a simple bit of maths to do. I should be okay. I've just got to find x now. Now, plus 822 on one side of the equation, if I take it across to the other, it becomes a minus. Minus 822. 0, I'm not bothered with. Plus 333 on the other side of the equation becomes minus 333 equals 3x. So I'm getting 3x on its own. Let's just run a calc. Just to show you, although we can do this in our head. 19 minus 822. That's not right. We'll just do them all as positives and then minus them all at the end. I'm making a mess of this. 19, add 822, add 333, all of those, and I'll make it a minus. Minus 1174. Minus 1174 equals 3x. Divide both sides by 3. Divide by 3 equals 391.3. So minus 391.3 equals x. Done. So my enthalpy change is minus 391.3 kilojoules per mole, because all of these are in kilojoules per mole.